Welcome to this quick lecture on Bayes theorem. Okay? Bayes theorem is named after an 18th century British mathematician called Thomas Bayes, and is actually the mathematical formula for computing conditional probability. Okay? So conditional probability on its own is the likelihood of an event occurring, calculation of the likelihood of an event occurring based on previous events having occurred in a similar circumstance. So it gives us a way of calculating or updating our probabilities, given that we have an additional evidence. Okay, so it is a way of finding a probability when we already know some certain other probabilities. It's widely used in the field of machine learning and in making predictions. It relies basically on prior probability distributions in order to generate posterior probability. In prior probability, in order to generate posterior probability, we are going to look at these two concepts. Number one, prior probability. Probability is the probability of an event occurring before new data is collected. In other words, a rational representation or it represents the best rational assessment of the probability of a particular outcome based on the current knowledge. In other words, what we have before an experiment is performed. On the other hand, the posterior probability is actually the revised probability of an event occurring after taking into consideration. Now, this is very important. After taking into consideration the new information. Okay, so posterior probability is calculated by updating the prior probability using Bayes theorem. All right. So in statistical terms, the posterior probability is the probability of an event A occurring, given that event B has occurred. Okay, we are basing on what has happened, basing on this. Okay, so before we can do this, before this conditional probability is possible, we are supposed to be able to know what this is, the value of what is the probability of B given A. We must have calculated this. We must have calculated the probability of A, and we must have calculated the probability of B. So the formula is given like this. The probability of A given B is equals to the probability of A multiplied by the probability of B given A, that which we already know, all over the probability of B. Okay, so let's start to look into it by way of example before trying to make a proof. Okay, imagine that we have 100 persons in a party, and when you made a tally, you got these numbers that out of the 100 persons that are in a party, you calculated that 40 of them are men. Okay, and you calculated that others, maybe women and children, are 60. Okay, we have 100% total. Then out of the 100 persons that are male, 20% of them that are not male are wearing pink, and in fact, 25% are wearing pink, and yes, 75% are not wearing pink. Now, out of the persons that are wearing pink, 5 men are wearing pink, while 20 others are not wearing pink. Now, what's the calculation? It says the first thing to calculate is the probability of a person being a man. Okay, now out of the number of persons, we calculate who are men, 40 of them. So 40 over 100 gives us 0.4. So the probability of getting a man in that party is 0.4. Now, the probability of those wearing pink, the probability of having a person wearing pink is the number of persons wearing pink, which is 25, all over the total number of persons in that party. And so we have 0.25. Now the next thing is the probability that a man wears pink, which is denoted by the probability of pink, okay, given that the person is a man. All right, probability of pink given the probability of man, probability of pink given the probability of man. Okay, now we have how many as men? 40 men. Okay, then among the 40 men, how many are wearing pink? Says 5. So we do 5 over 40. Okay, now the next is the probability that the person wearing pink is a man. In other words, what's the probability of man given the persons wearing pink? When you look at the persons wearing pink, what is the probability that the person wearing pink is a man? So we have the persons wearing pink, which is 25 persons. And if you do, only 5 men are wearing pink. So if you do 5 over 25, you are going to get 0.2. But we're not trying to calculate it this way. We want to use Bayes formula to calculate it, because this is what we are looking for. What's the probability of pink? What is the probability of a man, given that we know the probability of pink? And the probability of pink is what here? What's the probability of pink? 0.25. Okay, 0.25 is the probability of pink. That is 25%. Okay, so if you divide it by the number of men, you are going to get it. Okay, but we just want to use the Bayes formula as stated here. Now the probability of man is 0.4 multiplied by the probability of pink given man, which is 0.125, divided by this is going to give us this as calculated here. Okay, now let's proceed further to do a general expression of the Bayes formula. Now given, let A in this case now be the, A in this diagram be man, and the B in this diagram represent pink, just as we have in the previous slide. So, and we have STUV as the contents of whatever the values represent. Now, let S be the probability of man wearing pink, yes, and let T be the probability of the probability of man not wearing pink. Is actually a man, but it's not wearing pink. Okay, man not wearing pink. Now U is going to be the probability of not man wearing pink, not man wearing pink, and the probability V equals to the probability of not man not wearing pink. All right, not man not wearing pink. Okay, so that is it. Now when we compute, now we are trying to do something. Now what is the probability P of A? What's the probability of man? In this case is ST over this. So the P of A is this over is ST over this. Okay, then what's the probability of what's the B? The probability of pink. What's the probability of A giving, probability of B here giving what? A. So inside of the probability of A, inside of the persons that are A, that is man, what is the probability of B inside it? It is S over T. Okay, so when we evaluate this, we are going to be left with this. Now if we do it the other way around, in this case we are going to be looking at what is the probability of B, and in this case we are going to look at what is the probability of A given B. Okay, so if we do it that way again, what is the probability of B, the whole of this place? We get something like, let me pick another color. Okay, what is the probability of B Okay, inside of this, we are going to get S plus U all over S plus T plus U plus V. Okay, now we are looking at B in total. We are looking at B now. It says, what's the probability of A giving B? Now we have this. Look at the whole of B, S and U. And what is the probability of A there? S. So this is A. Sorry, this. Okay, this one now is S all over S plus U. So if we multiply S plus U over S plus T plus U plus V, multiply it by S over S plus U. This will cancel this, giving us S over S plus T plus U plus V. Okay, meaning that this now is equal to this thing. Okay, the next slide we'll see. So having calculated this, we can infer that this and this are the same thing. So if we divide both sides by P of B now, divide here by P of B, okay, we'll notice that this will cancel off this, leaving us with this particular place. And that is our formula, base formula. All right, and if proven it. Then let's look at an example finally. It says, imagine that you are to have an interdepartmental football competition and you quickly stumbled into a data set that shows the following. Number one, that 50% of rainy days starts off cloudy. 50% of rainy days starts off cloudy. Okay, PCR equals what? 0.5. And cloudy mornings are common with about 40%. In other words, P of C is equal 0.4. Okay, it says we are in a month that is usually dry. Only 3 of 30 days tend to be rainy. So we are going to do something like 3 over 30 times 100 over 1. Okay, this cancels this, this cancels this. So we have 10%. Okay, so and 10% is equal to 0.1. So the probability that we have rain PR now is equal to 0.1. Calculate the chance of experiencing rain during the day. Okay, so we can now calculate the probability PR, probability of rain, given that we have a cloudy morning, by this formula that is here. So when we plug in the values of PR is going to be 0.1 and the probability of cloud giving rain is 0.5, and then the probability of cloud is 0.4. When we calculate it, we have this, and that is the conditional probability, okay, that we have rain given that we have a cloudy day. Okay, we are going to end it here. Thank you very much.